Today's video clip is from the 9th of October 2016. It was fairly overcast. There was some very nice flying late afternoon after a very calm start of the day, so fairly late going out for flying up to Craigowl. And as it was quite an overcast day, what I'm going to do is cover briefly, not going to go into the detail that we do when we're teaching, but just to briefly cover some of the Met reports. Also, the sky was quite interesting, and at various points in the video you'll see me pointing up to the sky, and I'll try and narrate what is happening. So we're going to start with a look at the F215. Now, I started paragliding way back in the day when, to get these reports, it was about £8. They came back via the fax, and you didn't really have any internet access to any of this. So I actually joined the local flying club and used to go out flying with some of the instructors there, as well as some of the senior members of the club, and they used to come out paragliding with me. So I've actually taught paragliding to quite a few PPL instructors, airline pilots, fast jet pilots, stuff like that. One thing that's never surprised me is the almost total lack of training in proper Met aviation in the UK. So the various bits that are popping up on the screen, I've actually got up on the second screen so I can easily read them. And the key thing about all of these is always check the validity. So you can review the video and go back through this. Essentially, the F215 has graphical representation, basically a map, and it has indications of weather fronts, weather zones on that. It also has textual information. These are broken down into several sections. So you have the zones or areas, depending how you phrase it, and within those you have what they describe as surface visibility and weather information, and you have cloud information, and there's a further box sections column where it's giving you some temperature related information. There's a lot more to it than just the temperature. It's not really about that, it's to do with altitudes, but I'm not going to be covering that in this video. Now, a good way of thinking it is not as the Met Office has actually worded it, but instead of thinking about the surface visibility and weather, think about it as the horizontal visibility and the weather that restricts that visibility. In the same way, instead of thinking just about cloud, think it about as the vertical visibility and the cloud and cloud types that affects vertical visibility. The last column, for a wee bit specifics, is essentially the altitude at which freezing point occurs. You also have some more information on the bottom, giving you effectively a key to the mapping and the textual information. You have information as to the time that the report was issued by the Met Office, and in the top right you have validity information. So we'll briefly cover that. So this is a forecast weather chart for weather below 10,000 feet, known as the F215. In the case of this particular one, the validity reads as 09140020092300Z. OCT 16 front oblique zones valid at 091800Z. None of that is actually complex, it's just a case of looking at it and decoding it. Now, as stated, this video is from the 9th of the 10th 2016. So the key to answering questions for yourself is to look at the answers which are often within the questions. So in the case of this, the 09, when you scan along the whole thing, you look at the balance of probabilities, because it's handy to be able to work out answers rather than chalk and talk type of training where you're told to remember things. That doesn't work well. You're better being told how to decode, how to work out things, how to check and recheck. So what we actually have here is on the 9th, with the validity starting at 1400, 2 also on the 9th, validity ending at 2300. The Z refers to Zulu time. So if we're in summertime in the UK, those times compared to what you see on your watch will be out by 1 hour. If we're within the winter time, they will actually be accurate times. The next section, the middle bit of this, often catches folks out if it happens that the date on the month is the same as the numerical last digits of the year. In this case, as we're on the 9th, this doesn't apply. So it's October 16 is October 2016. The last part of this validity block is fronts and zones valid at 091800Z. So those that are paying attention and thinking will see the pattern again. So essentially, if you think about the graphical image, which has vector arrows on it showing movement of fronts, movements of zones and areas, what you have here is a snapshot time where those vectors have a value, for instance 5 knots, 10 knots, 15 knots and slow are all on this particular one. So you have a direction and you have a speed of movement in that direction. If you have that information and you're looking at a different part of the time for the chart other than the actual snapshot validity time, you can move the boundaries backwards or move the boundaries forwards in your mind for the relevant time that you're out flying. So essentially, in essence, you have a snapshot image which is valid for 1800 Zulu, and if you are flying earlier at 1400 Zulu, or if you're flying later at 2300 Zulu, obviously subject to daylight, you can move the borders backwards and forwards. Now, when we look at what they call the surface visibility and weather, I would advise you thinking of horizontal visibility and weather. We're looking at the relevant area on the chart for where we were flying today. In the case of this particular chart, it happens to be area or zone B. Nice and simple one on this. So surface visibility and weather for B is given as 30 kilometers. Horizontal visibility, I'm adding in extra words for clarity, so 30 km NIL is what the chart says. So 30 kilometers horizontal visibility due to nil weather. Doesn't mean there's no weather, it means there's no weather that would cause concern for a pilot. The second line is ISO, isolated 3000 M PR LAN FM 21Z. Looks complicated, sounds complicated. It's actually very simple. You start off with the best part of the visibility, then you start stating where there will be restrictions or limits in that visibility. So as you read this box going from the top of each box downwards, you should see less visibility and you should see the reasons for the less visibility. So in the case of line 2, what it's saying is isolated, so in other words within some parts of zone or area B there will be an isolated circumstance where the visibility is reduced to 3000 meters due to mist. It's further stating that this will be over the LAN, over the land. FM is a time information bit. It's saying over the land from 21 Zulu, the visibility will be restricted to 3000 meters due to mist. The last one on this particular nice and simple chart is ISO hill FG. Basically they're saying you're going to have some cloud on the hill, isolated hill fog. Okay, so that covers the surface visibility and weather, which I would refer to as the horizontal visibility and weather, because it's not just at the surface, it's at different altitudes. And now we'll look at the vertical visibility, which is described on the chart as cloud information. I'll read the first line. Isolated SCT/BKN CU SC. Then there's some stuff in the brackets that I'm going to skip over on this information video. And 015-030/060-080. Again, when you're reading it, or if you're even looking at it when you haven't been trained for this, it looks complex. It's not, it's simple. Decode on that ISO: isolated, SCT/BKN, scattered or broken, CU, cumulus, SC, stratocumulus. Again, I'm just skipping part here just for simplicity. Then 015-03 is 1/2 of a fraction. The other half is 060-080. All it's saying is that within B, which is in this case a very large area, going from the Northern Isles all the way down Scotland, Wales, down to, what would that be, Penzance, a very, very large area. Within that area, what they're saying is that you have an isolated, scattered or broken cloud of the cumulus and stratocumulus variety, with a base that ranges between 1500 feet and 3000, and the tops of the cloud ranging between 6000 and 8000 feet. Further goes on with another line saying blah blah blah, all the way, bit more information there. Stratus cloud, lower level, but it's qualifying it as over the land from 21 Zulu. So as you'd expect, once the sun's setting, humidity rises as the temperature drops. They're basically saying you're going to have a bit of low stratus cloud tracking along the land. The actual reading in code is ISOL SCT/BKN ST 003-006, other half of the fraction, the slash if you like, 015, then the location type code LAN, the time information FM 21Z. So isolated, scattered or broken stratus, with a cloud base of 300 feet to 600 feet, with the cloud tops of 1500 feet over the land from 21 Zulu. This is stuff that we cover day in day out with students to make sure that they're not being taught chalk and talk style met information, but instead they're being taught how to decode this. So several years down the line they maybe forget some of the details, but because they're taught how to decode it, not as in ABC equals whatever the code stands for, they're being taught how to break it down into its structure, and from the structure easily work out and remember what all this information decodes to. Anyway, we'll go to skip over the 0 degree C stuff. Essentially you also check at the bottom, and it has an outlook, and in outlook it's saying in this case at 6 o'clock in the morning on the 10th, so the following day, you've got isolated fog, freezing fog forming over land. Again, if you look backwards in time, that makes sense to what you'll see on this chart for earlier on in the day. If you've got relatively high humidity, temperatures dropping, you're going to tend to get this mist, you're going to tend to get this low cloud. Not too surprisingly, by the early hours of the morning, with a noticeable drop in temperatures we get into the winter, you're going to get fog and freezing fog, and mainly over land, because with an otherwise clear sky, temperatures will drop more. Now we're moving on to the F214, otherwise known as the spot wind chart. Unfortunately, because this was originally designed for things like faxing out, as I mentioned before, it used to cost me about £8 to get the weather reports through the fax machine. It tends to come out as incredibly pixelated, and as I'm busy editing this video in the early hours of the morning, I'm not going to spend a couple of hours sharpening up images, basically retyping them. So essentially F214 has boxes on it. It's a graphical chart with some textual information. You're looking at the map of the UK, and the easiest way, and the way I teach it to students, is if you think about each of those boxes as being a very, very tall flagpole with a number of flags situated at different altitudes. What they're giving you is wind information, the wind information as a vector. So they're giving you a direction and a strength. They're also doing it at set heights, which are the same on every box, and as well as that, at those heights they're also giving you temperature information. Now for those that are more used to looking at what they call it, the RAS charts, etc., basically they're computer models based on this information. So while they may look to be incredibly accurate, they're not actually based on real data. It's a computer that's taken real data at a number of set points and worked out what it thinks it should be in between those locations. When you go back to as near as you can to the source code, if you wish, you tend to have a better judgment of what the day will be like regarding thermals. Now for those that have been looking at the sky, what we actually have been seeing today is winds which have an indication from the cloud base approximately 500 feet above the hill, and when you're looking as this point of the video to the left and right, if you carefully examine the clouds, they're actually showing that the wind at the cloud base and towards the cloud tops is much more northerly, and yet I'm flying the south side of the hill. So at various points in the video I'll be looking back past the pickup, past the compound, and what I'm doing there is I'm looking at wind turbines which are at the wind farm which is over the back of this line of hills. Now so long as those wind turbines are still showing southerlies, then I know that the low level wind that's flowing up and down, crucially down as well, over the ridges and the hills is still southerly. The big risk here is that if the wind switches round and you're on the lee side, that suddenly becomes, the south side of the hill would suddenly become the lee side, then you can get downdrafts. So I'm paying very close attention to what the cloud information, basically the wind 500 feet above me, is telling me. Now when I look at the weather chart, the 214s, it's exactly the same situation as the 215s. I'm looking at the validity. There's a whole load of decode stuff which I'm not going to cover on this video. I'm looking at the boxes and I'm decoding the information. For our particular location we've got two boxes, one situated at 5730N 0230W. So basically 57.5 degrees north, 2.5 degrees west. That's to the north of us. If you think the coast, not on the east coast, but the north facing coast above Aberdeen. There's another box which is very relevant for my flying area, which is 55N 0230W. So 55 degrees north, 2.5 degrees west, and effectively that's down in the borders. Now as I'm situated between the two of these videos, what I'm doing is I'm looking at the data on one, sorry not videos, or boxes, I'm looking at the data on one, I'm looking at data on the other, and I'm working out what the interpolation, what should be the trend between the two. In addition, I'm also looking at the location of the centre of low pressure areas and highs, and using 20 odd years of experience, which clearly helps, to work out what we should have. I'm looking at cloud information. Now the cloud information is from the F215, and what I'm looking there is what's the cloud cover. If I'm flying a southern site, south facing site I should say more clearly, and there's going to be very little cloud cover, then I would expect a lot of sun at certain times of the day on the south side of the hill. So when I have thermals at a low level due to the sun on the hill, and when I have an atmosphere that is relatively unstable, and when from the F215 I have a high cloud base, then I have a potential for not just thermal flying day, because you can thermal fly low lit ridges, but you have the potential for a cross country day. However, if as the day is today. You've got an F215 indicating the cloud base will only be 500 feet above the hill. Even if the F214 was indicating good thermal conditions, there's no point trying to go anywhere because you've only got 500 feet before you're at cloud base. There's also the legal issues if the cloud base was below 3,000 feet. If the cloud base is above 3,000 feet, you've still got 1,000 foot vertical separation, so again, you've got to look at that. And for this particular location, we've got Class A airspace at approximately 5,000 feet above the hill, so again, that provides limits. So there's a whole load more stuff which we cover with students. We've not looked at the METARs or the TAFs for this particular day, but these are all things, as well as the Mark 1 eyeball, that we cover, getting students to look at the sky, look at the various indicators, even things like smelling smoke that can be coming from a fire 5 miles away, and decoding all this information on a day-to-day basis to build up their level of experience before they're out on their own. Anyway, I hope you've enjoyed this video. It's a bit different from our usual, but as I say, with an overcast day, you're not exactly getting brilliant lighting for filming. So hopefully this is not a waste of time to look at some of the Met issues. The clip you can see here just now, you should see these clouds there, and that's very decidedly the end of the day, but still showing a northerly drift with the clouds, despite the fact that the wind here is southerly at the hill, and probably for at least 300 feet above the hill. Good night. Aye.
Oh no. Mummy, that wind is definitely